We treat our new artificial intelligence systems like modern oracles, embedding them in our workflows and connecting them directly to our databases, granting them full, unchecked administrative control over our most critical infrastructure, assuming their underlying code is inherently secure. But this chart shows exactly how dangerous that assumption has become. In 2025, critical AI vulnerabilities surged by 34.6%. Meanwhile, standard software vulnerabilities grew at only 17.9%. Flaws in AI architecture are multiplying twice as fast. By rushing to deploy these language models and inference engines at enterprise scale, we have built a fragile technological foundation, and threat actors are already treating it as their primary target. Building a firewall around a dynamic machine learning model is often a wasted effort. Because these systems pull data from countless external sources, the old concept of a static, secure perimeter no longer applies. Right now, there are hundreds of thousands of AI inference servers, like Llama and Chroma instances, sitting completely unprotected on the open internet. These exposed nodes often run outdated, unpatched software. Anyone with an internet connection can access them to scrape sensitive business analytics, extract human resource records, and pull personally identifiable information. Relying on generic compliance checklists while leaving the front doors to your data pipelines wide open is an exercise in theater. Real defense requires understanding how these systems are actually compromised. Attackers know they rarely need to breach a server directly. Instead, they target the supply chain, poisoning the underlying data pipelines that the AI relies on to interpret the world. One method is tokenization drift. Before a language model can read text, a tokenizer fragments the words into smaller pieces.
Malicious actors are now uploading subtly altered models that chop identical text into twice as many distinct tokens without ever touching the model's core weights. Because the model still generates coherent answers, the victims notice nothing until their computing costs double and system latency spikes to handle the artificially inflated workload. The true danger is the security bypass. These altered tokenizers can manipulate how the AI interprets input. A user typing a benign word like yes can be silently translated by the tokenizer into a hidden executable malicious command. This bypasses legacy security tools entirely. The attackers weaponize the AI's own language processing capabilities to smuggle instructions past the guards. That risk compounds as we move from simple chatbots to agentic AI, systems engineered to make autonomous decisions, orchestrate workflows, and actively wield system tools without a human in the loop. To communicate, these agents often rely on Model Context Protocol, or MCP, servers. Recent scans reveal that a vast majority of these servers run deprecated transport protocols, and dozens freely expose internal databases to the public via unguarded SQL execution tools. Agent-to-agent communication is emerging in the wild, where autonomous systems negotiate and pass data between themselves. Currently, these experimental frameworks are managing infrastructure with absolutely zero authentication. Threat actors are highly aware of this transition. North Korean operatives are already deploying deepfake personas and leveraging AI chatbots to pass technical interviews, successfully infiltrating the payrolls of Western companies. The next logical step is criminal agentic AI. Instead of a human hacker trying to breach a system, an autonomous agent can continuously hunt for vulnerabilities. If an exploit fails, the agent analyzes the error and rewrites its own payload in milliseconds. The threat landscape has mutated into a self-driving, reasoning adversary that attacks, evaluates, and adapts far faster than any human security team can respond. Building static walls is mathematically useless against an adversary that can rewrite its own attack code on the fly. Defending these systems requires a completely different approach: AI red teaming. This is the practice of using adversarial tactics as a continuous, diagnostic defense mechanism. Modern security frameworks like Deep Team and Wiz's AI Security Posture Management are specifically designed to relentlessly attack an organization's own AI infrastructure. They automate complex simulations, executing multi-turn jailbreaks, testing for prompt leakage, and launching goal theft scenarios to see if an agent can be tricked into abandoning its original instructions. The only reliable way to patch a vulnerability in an autonomous system before a criminal agent exploits it is to use a controlled, automated adversary to find it first. As agentic AI becomes deeply embedded in global supply chains, financial networks, and critical infrastructure, the potential attack surface will expand infinitely.
In this environment, cybersecurity functions as a high-speed wargame. It requires a continuous cycle of moves and countermoves to keep pace with an automated adversary. To survive this transition and protect the immense power of these systems, organizations must permanently adopt an adversarial mindset, turning their AI's intelligence against itself.